Good morning all. So in last class we have defined what is linear independence and dependence of constant vectors and vector functions. So we have seen an example of a constant function. So how to check whether if you are given a set of constant vectors, how they are linearly independent or not. Now in today's class we will see a few examples of vector functions. So let us see a few problems. So check whether the vector functions defined for all t is linearly independent or dependent on any interval a less than or equal to t less than or equal to b. So the first question is, so you are given the vector functions phi1 of t equal to e raised to t, and phi2 of t is e raised to 2t and 2e raised to 2t. So we need to check whether the vector functions phi1 and phi2 they are linearly independent or not. So what we do is, so let us assume that phi1 and phi2 are linearly dependent. On closed interval AB. Now if they are linearly independent, then there exist numbers. So you can find numbers C1 and C2 not both 0 such that, so when you take C1 phi1 of t plus C2 phi2 of t, so that will be equal to 0 for all t belongs to closed interval AB. Now C1, so let us substitute phi1 and phi2 here. Okay, so you will get C1, so phi1 is e raised to t plus C2 e raised to 2t, 2e raised to 2t equal to 0. So that will give us the equation C1 e raised to t plus C2 e raised to 2t is equal to 0, and you will get C1 e raised to t plus C2 2e raised to 2t equal to 0. Now you can multiply by e raised to minus t on both sides. So you will get C1 plus C2 e raised to t ಆಗುವುದು, then C1 plus C2 2e raised to t equal to 0. Now both are equal to 0, so this will imply C1 plus C2 e raised to t will be equal to C1 plus 2C2 e raised to t. So ഇത് രണ്ടും equal ആവണം. And now C1 will cancel out both sides, so that will give C2 e raised to t equal to 2C2 e raised to t. So this will imply 1 equal to 2, which is going to be a contradiction. So you will get 1 equal to 2. So therefore it's a contradiction. So therefore we started with the assumption that they are linearly dependent. So therefore our assumption is wrong. So that implies phi 1 and phi 2 are linearly dependent. Linearly independent. So let us see one more example. So you have phi 1 of t equal to 2 e raised to 3t, 3 e raised to 3t and minus e raised to 3t. And phi 2 is 4 e raised to 3t, and then you have minus 5 e raised to 3t and 5 e raised to 3t, and phi 3 is 5 e raised to 3t, 2 e raised to 3t and e raised to 3t. So let us consider the equation C1 phi 1 plus C2 phi 2 plus C3 phi 3 equal to 0. So that will give us C1 2 e raised to 3t, then 3 e raised to 3t and minus e raised to 3t, then C2 4 e raised to 3t, then minus 5 e raised to 3t, 5 e raised to 3t plus C3 5 e raised to 3t, 2 e raised to 3t and e raised to 3t equal to 0. So e raised to 3t is common in all the components. So that will give us the equation 2c1 plus 4c2 plus 5c3 equal to 0. Second equation is 3c1 minus 5c2 plus 2c3 equal to 0. And minus c1 plus 5c2 plus C3 equal to 0. So this is a system of the form AX equal to 0. Now the determinant kandupidikka. So if you take determinant of A, so that will give, so take the determinant of the coefficient matrix. But determinant equal to 0 anengil, that means there exists a non-trivial solution. So you have 2, 4, 5, 3, minus 5, 2, then minus 1, 5, 1 varum. So that is 2 into minus 5, minus 10, then minus 4 into 3 plus 2 varum plus 5 into 15 minus 5. So that is minus 30. Then you have minus 20. Then 50. So the determinant is equal to 0. So determinant of A equal to 0. That implies the system has a non-trivial solution. So the system has non-trivial solution. So if the system has non-trivial solution, that means not all Ci's are 0. So since not all Ci's are 0, that implies phi 1, phi 2, phi 3, they are linearly dependent. So that is the required solution. Now let us see one more problem. So the next question is determine the value of k so that the given set of constant vectors is linearly dependent. So you are given the constant vectors V1 is K2 minus 1, V2 is 1 minus 1 2 and V3 is 3 7 minus 8. അപ്പോൾ നമുക്ക് കോൺസ്റ്റന്റ് വെക്ടേഴ്സ് ആണ് തന്നിരിക്കുന്നത്. You need to find out K such that the vectors are linearly dependent. So let us first write down the equation C1 V1 plus C2 V2 plus C3 V3 equal to 0. So that gives C1 K2 minus 1 plus C2 1 minus 1 2 plus C3 3 7 minus 8 is equal to 0. So that implies the equation നമുക്ക് KC1 plus C2 plus 3C3 equal to 0 കിട്ടും. Then 2C1 minus C2 plus 7C3 equal to 0. Then minus C1 plus 2C2 minus 8C3 equal to 0. So not all Ci's are 0 since the given vectors are linearly independent. So that implies determinant A will be equal to 0. Non-trivial solution until determinant of A must be 0 where A is the coefficient matrix. Okay. So let us write A now. So A nu parayunnathu that will be the matrix K2 minus 1, then you have 1 minus 1 2 3 7 minus 8. Okay, so let us calculate determinant of A. Determinant of A will be K into 8 minus 14, then minus 1 into minus 16 plus 7 plus 3 into 4 minus 1. So that will give minus 6K, then plus 9 varum, then plus 3. So determinant of A equal to 0 implies, so minus 6K plus 12 is equal to 0. So therefore K will be equal to 2. So that is the required value of K such that the given set of constant vectors are linearly dependent. So with this we'll stop for today. We'll see few more problems in the coming classes. Thank you.